Similar to the linear motion essentials, I have another one on projectile motion essentials. The idea is the same. This is just a quick overview. This is not an in-depth review. Just some key things that you should definitely keep in mind. So the first thing is you need to know SOHCAHTOA. You don't need to memorize it. It is on the equation sheet, but you need to know how to use it. If you don't, make sure you do. Next is x direction, y direction, x velocity, y velocity, x acceleration, y acceleration. You have to keep them all separate. The only thing that can cross between x and y is time. Vectors have components. That's where SOHCAHTOA comes in to break up those components into their x and y. Now, one thing I want to point out for the majority of projectile motion questions, the acceleration for the x will be 0, which means when you look at the second kinematic equation, it will narrow down to delta x is v initial times time. The other two kinematic equations won't be useful for you for the x direction. In the y direction, the acceleration is 9.81 meters per second squared down due to gravity. In fact, that's the next point, gravity and projectile motion. We talked about this example in class. You have two bullets. They're the same type of bullet. One is dropped from a height of 1 meter and the other is fired horizontally from a height of 1 meter. And the question was which one lands first. The answer is they land at the same time. Both of them have an initial y velocity of 0. The gun fired the bullet horizontally, which gives it a y initial velocity of 0. Both bullets are being accelerated 9.81 meters per second squared down. They both have a delta y of -1 meters. Therefore, they land at the same time. The last thing is how velocity behaves in projectile motion. In the x direction, it's constant because there is no acceleration in the x direction. In the y direction, if the projectile is launched upwards, it will lose velocity trending towards 0, reach the peak, hit 0 at the peak, then begin gaining negative velocity. If the projectile is launched horizontally, the y velocity will start at 0 and become increasingly more negative over time. If the projectile was launched at an angle downwards below the positive x-axis, the velocity will begin negative in the y direction and continue to become even more negative over time in the y direction.